minimum variance. So it has the minimum variance among all unbiased estimators of the parameter. Estimators of the parameter. Whereas if we take like UMVUE, so UMVUE is unbiased estimator whose variance is minimum for every value of the parameter. For every value of the parameter among all unbiased estimators. So if we consider the first statement, so if an unbiased estimator and a MVBUE is always UMVUE. So this is true because if an unbiased estimator is attaining like minimum variance bound, so then like no other unbiased estimator can have smaller variance. So therefore it is uniformly minimum variance unbiased. And statement 2 says an MVBUE of a parameter theta must be sufficient for theta. So that is also true because like if we take by Rao-Blackwell theorem, so we have like, suppose if S of x is sufficient statistic, so then expectation of t given S is also unbiased and has no larger value and has variance no larger than t. So that means, so t already like here like t already has sufficient minimum variance. So that means equality must hold. So variance of t given variance of expectation of t given S, expectation of t given S is nothing but variance of t, and this is possible only when t is function of sufficient statistic. So therefore statement 2 is true. Statement 3 says an MVUE is always MVBUE. This is also not necessarily true because a UMVUE, this is guaranteed, it only guarantees minimum variance among unbiased estimators. So it need not attain a variance bound such as like Kramer-Rao lower bound. For example, like for many distributions UMVUE exists but does not attain the Kramer-Rao lower bound. So therefore a UMVUE need not to be an estimator that achieves the minimum variance bound. So statement 3 is false. So option A will be the correct answer.